Okay, so today we'll solve mathematics GATE 2022 question from ordinary differential equation. This is the question number 19. It's saying that the initial value problem, it is that dy by dx equals to cos xy for x is in r and y at the point 0 is y naught, where y naught is a real constant, has unique solution, first option, and the other option saying exactly two solution or infinitely many solution or no solution for this initial value problem. Okay, let's solve this one. And so in order to solve this, so this is the NPTEL reference, you can look at it. Okay, so we will first state one global existence and uniqueness theorem, from where we will deduce this result. Okay, so what is this existence and uniqueness theorem says? This is basically global existence and uniqueness. And uniqueness theorem. So it is saying that let fxy be a, so two assumptions are given. Assumption one is this is function be a continuous as a function of two variable, so this is option one, assumption one, and assumption two is the function is Lipschitz with respect to the variable y. So Lipschitz continuous in y, mean the second variable. So what is this Lipschitz condition? It is saying that mod of f of x y1 minus f of x y2, so this should be less than equals to some constant times mod of x y1 minus y2, and where x will lie in the, where x belongs to some region AB and y belongs to the whole real line, right? Means y1 and y2 should be, so therefore y1 and y2 also in the whole real line. So this should be true if and if a less than x naught less than b, then the OD, the corresponding ordinary differential equation, what is the OD? dy by dx equals to f of xy, and the initial condition at some point x naught it is y naught. Then it is saying that if fx is continuous in both variable and Lipschitz continuous in second variable, and then this OD has a exactly one solution, mean unique solution, has exactly one solution, y equals to some yx on the interval where you are talking about a less than x less than b, so mean the all x in AB. So that's why it's saying that global existence and uniqueness theorem. So therefore in our case, what is, so our case it is dy by dx equals to cos of xy, and y at the point 0 is y naught, right? So we have here, we have what we have, dy by dx equals to cos of xy, right? So this is the fxy, and y at the point 0 is y naught, and x is in real number, right? So where fx is cos of xy, so we have, so note fxy here is cos of xy. So clearly this is a trigonometric function, right? So this is a continuous in all R2, so it is also both jointly continuous. So cos of xy is continuous on R2, right? So this is continuous function in whole R2 and as a jointly continuous, right? And the second option, we have to check that this is Lipschitz. So that we have to prove that cos of xy is Lipschitz continuous with respect to the second variable, right? So in order to proving this, one way to proving then some function is Lipschitz, the mean value theorem is very useful for this, so we will use that. So take 2 points y1 and y2. So we have taken 2 points, and what is saying that, so we will use the mean value theorem with respect to the variable y. So by mean value theorem, so clearly this is differentiable and continuous, right? So mean value theorem is statement is satisfied. So by mean value theorem, there exists some c in between y1 and y2, right? y1 and y2, such that what will happen? Cos of x y1 minus cos of x y2. So this should not modulus, this should be less than equals to derivative. So derivative of cos of xy, so this is with respect to the y, right? So derivative with respect to y at the point c. So let me write as a f del f by df or del f, let me write here fx is cos of xy with respect to y at the point x comma c, right? And y1 minus y2. So from mean value theorem we will get this. And what is del f by del y? Here del f by del y at the point x comma c, what it will be? It will be derivative of cos of xy, right? So it will be minus x sin xy at the point x comma c. So therefore it is minus x comma x sin cx, right? Therefore by taking mod, what you will get? Cos of xy1 minus cos of xy2. So this should be modulus of x sin cx into mod of y1 minus y2. Now let's take x to be some AB. Now let x belongs to on some interval AB, some fixed compact interval, right? Then what will happen? Cos x y1 minus cos x y2, this should be less than So mod, so this will be mod x which is less than b, so it is b, right? So mod b, and mod sin cx, it will be mod sin cx, so this is less than 1, right? Into mod y1 minus y2, so this is less than mod b times mod y1 minus y2, so which implies cos of xy is Lipschitz on AB, right? And y is, it is y is in whole real number, right? On x belongs to this and this, right? So therefore we have satisfied the condition 1 and 2 for this theorem. So therefore we can say that, suppose we have also taken x to be such that 0 contain this interval, 0 belongs to AB. You have taken some interval so that 0 contains it, and we have given that the initial condition is given at y0 equals to y0. So by this theorem, then this OD has exactly one solution for all x in AB. Therefore, by the above theorem, the initial value problem has unique solution on x belongs to AB such that 0 contains the interval and y is in R, right? And now note that this AB is arbitrary, right? Now note here this interval AB, where AB are arbitrary, so that it will contain 0, the interval AB are arbitrary. So therefore the theorem is true for any such compact interval, right? So which is same as saying that this has a means unique solution for all x in R, right? So why? Because suppose this does not have a unique solution in some way, so you can always take some compact interval containing that where this is not, you are assuming where this is not unique, then it will violate that theorem, because this is true for any compact set AB which contains 0. So therefore it has unique solution on R, right? So basically what the unique solution exists let me call it 1 star. So unique solution exists for star on any AB, right? On any interval AB 0, so that this contain this, and where AB are real number. So which is same as saying that this has a unique solution on all R, right? Which implies star has unique solution for x belongs to R and y also belongs to R, right? Because suppose it does not have a unique solution on somewhere, then you can always find an interval which will contain that particular set. So there it will violate that because this is true for any compact interval. there must have a unique solution, therefore it cannot happen. So it has a unique solution on x, all x in R. So therefore which option is correct? So this has a unique solution, so the option first number, option A is correct. This initial value problem has a unique solution. Okay.